You can now make filament at home. And no, I'm not talking about cutting thin strips of plastic and feeding them into a makeshift extruder. No. This is the Creality M1 filament maker. There have been multiple attempts in the past to create a true desktop extruder for making filament at home. Some products are already on the market, but they are super expensive, closing in at almost 10,000 euros. Or they come in the form of DIY kits with slow output rates. I have here two benches, printed with the same printer, identical settings. One of them is made with Elegoo Rapid PLA, and one with my custom mix color, first extrusion filament I ever made. Can you spot the differences? How about these Cali cats? I have some more examples to show you later, but first, let's talk about the big elephant in the room. Keep in mind that this is still a prototype, so ironically or not, there are still 3D printed parts inside of this. The hardware setup is almost finalized, but the software is receiving constant improvements and changes. Even compared to other YouTubers' videos, mine came with updated settings and menus, so it constantly gets improved. In the end, the package will consist of the M1 filament maker and the R1 shredder. And for me, that is really cool. Even though I didn't keep waste or poops from previous prints somewhere in a dark corner of my drawer, some people do. Better than those poops though, I think the appeal is in failed prints, as these are sometimes big, easy to keep track of pieces that can be easily smashed down and shredded into manageable size for the M1. Of course, you should not combine filaments, as you know PLA and PETG don't play well together, so making sure you know which scrap is which is vital in this process. But today we're here to talk about the M1, so let's get to it. Quick outside tour, it looks pretty finished for a prototype because, as I said, the hardware is almost finalized. On top we have the hopper, or the feeding funnel, where you pour the pellets or shredded waste. It has a nice top cover that fits perfectly. Inside you can see the filtering grate, but you shouldn't use this as the benchmark. The smaller pieces go in, the better filament will be, making melting it in a uniform fashion much easier. On the back we have some ventilation holes, along with the power input and the on-off rocker switch. Both 220 volt and 110 volt versions will be available depending on your region. On the front we have a big glass door with a nice handle and a display. Here is where you start your extrusion and adjust all the settings. Since this is not finalized, some buttons and functions don't work, but what works is adjusting settings. The default PLA-M is a good starting point, but this is not a one-button process. Depending on your pellets, their moisture and some other factors, you will need to experiment and find the right balance for you. In my case, with the white pellets that Creality sent over, I found the third melting zone to be better at 195 degrees, keep in mind that it's better to use the recommended settings until you get the hang of the full process. You can of course also adjust the traction speed and the extrusion speed. All these factors will affect the final diameter consistency of the filament. For this prototype, Creality advertised a diameter of 1.75 plus minus 0.07 millimeters, which is a bit over the commercial filament that you're used to, but the production version will have plus minus 0.05, which is on par with other commercial filaments. These numbers refer to 100% virgin pellets used for extrusion, which is the best case scenario. When using waste material, or poops, the purity of these, as well as the size, will determine the final diameter consistency, and Creality advertised this as plus minus 0.1 millimeters. Another place where there is a steep learning curve is the manual filament guiding. Let me load up some PLA pellets, start the batch, and I can show you. Of course, you can use other spools as well, not only Creality, but you'll need to input the correct dimensions. So we go here, and we have the width of the spool, the outer diameter, where the filament is going to get wound, and the bore diameter of the roll. These are very important to make sure that the device actually winds the filament correctly. Now would be the time to install the pull carriage, but I found it easier in my case to just guide the filament manually using pliers. Preheating from idle takes around 5 minutes. After preheating, you can start the pre-extrusion phase, and the whole point of this step is to set a constant pressure in the melt zones, flush the previous filament, and guide it to the traction motor. This part is what I find most difficult because it's more of a balancing act. You need to find the right speed and pulling force so the filament does not get too thin and break. Once I make the full bend, I like to wait until I get a visually consistent diameter and then cut it and feed it into the traction motor. In this case, a fully automated system would usually require a much larger machine and a significantly higher price point. And this current version is designed more of a semi-automatic desktop system that gives users more control over the filament making process and the do-it-yourself experience. Now the display will start reading the diameter of the filament passing through it, and once we see a consistent 1.75mm output, we can press Start Winding and attach it on a roll. From here, the process is pretty much automated. We close the door and wait. The display will have a handy indication of how much filament we extruded so far, and once there are no more pellets in the hopper and we see the filament diameter start to decrease steadily, we can stop production, cut the filament and remove the roll. At this point, I like to remove 1 or 2 meters of filament from the roll to get rid of the smaller diameter towards the end of the extrusion. That's it, we now have a roll of custom color filament. Some notes that I have here. Because of the nature of the process, the filament needs to be cooled down on its path to the traction motor, and that means fans. That results in a lot of noise, and I'm gonna give you a sample here. Keep in mind that these fans are mandatory for thermal management. Also, during the production process, I could smell the distinct sweet PLA. This is because this specific prototype doesn't have the HEPA and activated carbon filter that the production units will ship out with, but you can rest assured the production ones will not have this smell. From previous attempts, I can tell you it doesn't really take a lot of black master batch to darken a color. I tried to get a dark red to purple with this roll, and as you can see, I literally put only 2 pellets of black master batch, and you can obviously tell where those ended up on the roll. So again, with experience, trial and error, you'll find the right mix ratio for certain colors. For all these examples, I was only making around 200 grams of filament to get more time with the machine itself and the process. But I think if you produced batches of 1 kilogram, mixing the colors would have been much easier. Speaking of which, the current production capacity of this prototype is 950 grams per hour, but the final product will be right at 1 kilogram per hour. So not taking into account preheating and guiding the filament on its path, you can expect to have 1 roll every 1 hour, which honestly is much more than competitors at a similar price point. A nice way to know exactly how much filament you have on a spool is to measure it when empty. Even though we have the indicator on the screen for how much we extruded, this is more accurate and repeatable. So we made 189 grams of filament in the end from the 200 plus we put in the M1's hopper. There will always be something left over in the melt zone, and we also removed the last bit where the diameter is not so consistent. So let's take a look at some test prints. First, of course, the Benchy. This was printed on the Elegoo Centauri Carbon 2, a Core XY printer, pretty fast, but we'll get to faster printing later. We have 2 examples here, the black one from my own in-house made filament with the M1, and the tan one from Elegoo Rapid PLA. They both look good, and apart from the previous color bleed on the tan one, there are some other blemishes which honestly surprise me, because in my opinion, the black Benchy looks better. Moving on, we have the CaliCat. This is more of a calibration test print, so you can measure dimensional accuracy. Here again, on the overhangs, we see the in-house filament pulled ahead. Mind you, they were both printed with identical temperature settings and identical speeds. Impressive so far. Moving on to a tolerance test, these 3 were all printed on my brand new Bambu Lab X2D. The black sample is from Sunloop Matte PLA High Speed, and the others are on my own filaments made with the M1. All have the same print settings for speed and temperature, so with proper tuning there may be better results to be had. But again, I don't see a difference between the commercial filament and my own. Following up, we have a small vase where you can really see the color change result you can achieve if you get funky with the color mixes. Here I was still getting the hang of the temperatures and speeds for this filament on my Bambu Lab, so there are some surface defects clearly present. It was printed at 200 mm per second for the outer wall. This shows exactly why it's important to have dry pellets and dry filament when printing. And then I decided to push it. Bump the volumetric speed up, the minimum layer time all the way down, and crank the speed to 500 mm per second. At 225 degrees, this is the result. Extremely impressive in my opinion. Keep in mind, I did not really have time to dry these filaments in advance, so that may improve the results even further. But to print at 500 mm per second with a filament I made in my living room, that is really impressive. There are some places where the diameter differences are noticeable, but nothing major really. And I think this is the cool part, being able to make whatever color you want or color transitions in the quantity you need, not being tied to buying a 1 kilogram roll of filament for every small project, and none needing to wait for shipping. You need a specific color blend now, in more or less 1 hour, you have it. Extremely convenient. I also wanted to test the strength of this filament, so I printed some test samples. These black ones are printed from Sanlu matte high-speed PLA, laying flat on the build plate, and these ones are with my own filament. Let's break them down one after the other and see if there's any noticeable difference. This is by no means a scientific test, just what I can gather by myself with the force I applied to break them. Next, some standing samples from my own filament and with Elegoo Rapid PLA. Let's see how these break. Okay, so here again the commercial PLA needed a bit more force than my own filament to actually break it. I could sit here for days and make color blends, even experimenting with recycling PET bottles or throwing some coffee powder in the mix to see if it changes the smell of a finished product. There are a lot of possibilities here, but I think I got my point across, right? This device is about convenience, allowing you to make as much filament as you need, when you need it, in whatever color you need. The only drawback I see is pellet availability. I think most people should use pellets to make their own filament because it's the most consistent way to get there, and also you don't really have control over the final color if you use scraps from multiple mixed failed prints. But at the moment, pellets are not that easy to find or not cheap enough to make sense financially. So Creality may need to take a look at offering cheap pellets to support the M1's journey. As always, if you like the video, give it a thumbs up, consider subscribing to the channel for more tech videos like this one, and I'll see you next time.